Okay, I'm going to pick up where I left off yesterday. We're going to use a table of values to graph the quadratic function y equals 1/3 x squared. So first I would make a table of those values, and we begin by choosing some values of x and then plug them into the equation to solve for y. So here are my values of x. If I square a -2, I get a +4 because negative times a negative is a positive. And then +4 times 1/3 is 4/3. And we can just go on down the table and complete that. Now I've got sets of ordered pairs that I can plot on the graph. And then we connect those with a smooth curve. And notice how wide the graph is. The number in front of the x is positive, so it opens upward, and it's a really small number. 1/3 is a smaller number. It's a fraction, and it ends up being a really wide graph. So I want you to take note of that as we're going through these. Okay, so use the table of values to graph the quadratic function y equals -4x squared. So I challenge you to go ahead and pause the video and create your own table, and then continue the video and check it. And notice this one has a negative number. It opens downward, which is what we expected to happen, because negative people are frowning, right? They're sad, they're negative. And this is a 4, and notice how narrow the graph is. So when it was 1/3, when it was a smaller number, the graph was really wide, and when it was a larger number, the graph got more narrow. Okay, so to find the domain and the range, if you recall, the domain is the x values and the range is the y values. So unless there's a specific domain given in a quadratic function, and you can assume that the domain is going to be all real numbers. Because if you look back at this, like this previous graph that we just looked at, it extends forever, down, 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 and as it goes further down, it continues to get wider and wider and wider and wider. So the domain, the values that I can plug in for x, would be all real numbers. The range can be found by looking at the graph. For example, the range is the y value, so where does my y value start? If you look at this graph, the minimum value is here at +1. So if I look at this, it starts at 1 and it goes up forever and ever and ever in the positive direction. We're just focusing on the y values here. So my smallest y value is 1, and then it goes up forever and ever and ever. So the range would be all real numbers greater than or equal to +1. So for an example, let's look at this. We can find the domain and then the range. As you can see, the domain is going to be all real numbers, because this graph is just going to get wider and wider and wider as it extends down, and I can plug in any x value and get out an answer. So my domain is all real numbers. The y value is a little bit more specific, so if I go here and I look at my maximum point, the y value is at -1, -2, -3. So my my y values are everything below. It extends from -3 on down. So the graph opens downward. We find the maximum. The vertex is here at -5, -3, so we know that -3 is the maximum. So to find the domain and range, we know that the domain, once again, is all real numbers, and the range is everything down here below -3. So we say all the values of y that are less than or equal to -3. Okay, go ahead and pause the video and give this a try. Hopefully you got that right. Okay, so the width of the parabola. I kind of pointed this out to you already as we were going through here. But the coefficient of the x squared term in a quadratic function affects the width of the parabola. So when the absolute value of m is less than the absolute value of n, that tells us that the graph of m is wider than the graph of y equals nx squared. So we look at the coefficient, once again, on the x squared term, and the smaller number is the wider graph, and the larger number is the more narrow graph. Okay, as we learned earlier, the sign of the coefficient of the x squared term tells us the direction it opens. If it's positive, it opens up. Negative opens down. Okay, so if we're going to graph these functions on one coordinate plane, go ahead and make your table. Now that we have ordered pairs, we can plot them. Look at the x squared graph. Its coefficient is 1, so it has a smaller coefficient than g of x, which has a coefficient of 2. So we expect the x squared graph to be wider, and it is. It's the green graph. And the red graph is more narrow. Okay, so looking at 1x squared and 1/2 x squared, go ahead and make a prediction of which one you think would be more narrow. Okay, the red is the 1/2, and the green is the x squared, a positive 1x squared. The red's the 1/2 x squared, so they both open upward because they're both positive. But the green one has a larger coefficient, therefore it's more narrow. 1/2 is a smaller number than 1, and it is a wider graph. Okay. Go ahead and make a prediction. How do the shapes of these graphs compare? We graph x squared. We can graph g of x, which equals 3x squared. It's more narrow. And then the widest of all would be the 1/3 x squared. So we would say the graph of g of x is more narrow than f of x, and the graph of h of x is wider than f of x. Okay, so properties of the form f of x equals ax squared. So we know if the letter a, or the number a, is greater than 0, then the graph of f of x equals ax squared is going to open upward. We also know that if a is between 0 and 1, the opening of the graph will be wider than that of y equals x squared, which is the parent function. If a is greater than 1, then the opening of the graph will be much more narrow than that of y equals x squared. Okay, this is just kind of summing up everything we've discussed. If a is less than 0, then we know it's going to open downward. That means a is going to be a negative number. In addition to that, if the absolute value of a falls between 0 and 1, the opening of the graph will be wider than that of the parent function. And if the absolute value of a is greater than 1, the opening in the graph will be more narrow than that of y equals x squared. And when the absolute value of a is greater than 1, we say that the graph is vertically stretched by a factor of a. And if it's between 0 and 1, then we say the graph is vertically compressed by a factor of a. If you think about something that's stretched, when someone gets stretched, like I'm thinking of The Incredibles, when the one person, I think it was the mother got stretched. She ends up being real tall and thin because she was stretched. So vertically stretched, it gets skinnier. But when something's compressed, if you think about smashing a pop can, when you compress that pop can down, it gets wider. So that's what happens with the graphs. When you compress them, they get wider, but when they're stretched, they get more narrow. Okay, so if I want to graph y equals ax squared plus c, the y-axis is the axis of symmetry for graphs of the functions of the form y equals ax squared plus c. The value of c just translates that graph up or down. So we know the parent function passes through the origin 0, 0. So if we have this plus c out here, it's going to move my graph up or down. So when c is a positive number, then it just shifts my graph up. But when c is negative, it shifts it down that number of units. So graph the functions on one coordinate plane. F of x equals x squared, and g of x equals x squared plus 3. create your table to get your values. Now we can plot those points. We've got f of x equals x squared. And then we've got the g of x equals x squared plus 3. Notice it's this same graph, it's just been shifted up 3 units. Okay, so if we're going to plot f of x equals x squared and g of x equals x squared minus 2, g of x is the green one, or f of x is the green one, I'm sorry, and g of x is the red. Notice that it just shifted down 2 units. Okay, so your turn. If you're going to graph f of x, or go ahead and graph f of x equals x squared, the parent function, note that a equals 1 in standard form. So which way is it going to open? What is the vertex? What is the axis of symmetry? And then what is the vertex of the function g of x and h of x? And what is the axis of symmetry for each function? Let's answer these questions. Okay, so here's the graph of f of x equals x squared. Here's the graph of g of x. It shifted up 3. There's the graph of h of x. It's going to shift down 3 units from the parent function. Which way does it open? Of course, it opens upward because it's positive. The vertex is 0, 0. The axis of symmetry is x equals... The axis of symmetry is x equals 0. If we graph we've already graphed g of x and h of x. The vertex of each of them is 0, 3 and 0, negative 3. And the axis of symmetry for both is still x equals 0. Okay, so graphing a parabola defined by f of x equals ax squared plus c. Once again, we know if c is positive, then the graph has just shifted upward that many units. If c is negative, then the graph shifted downward that many units. And the vertex will be 0, c. And the axis of symmetry is always the y-axis when you're given a problem in this form. Okay, and I will give you a worksheet to complete in class for a grade.